Hello everyone. In this video I will be going over how to solve exponential equations. So our learning target is I can solve exponential equations with integer solutions. When solving exponential equations, we have to remember in order to use the properties of exponents, our bases must be the same. That will be our challenge, finding ways to change our base in order for our properties to work. Let's take a look at examples where our bases are the same and an example where our bases can be rewritten. Okay, so remember that's nothing new going back to our exponent properties. For example, if I had x to the fourth times y to the fifth, because one base is x and the other base is y, I was not allowed to simplify those. Okay, so we need our bases to be the same. Once our bases are the same, we can solve our equations. Okay, so taking a look at this first example, we have 4 to the 2x equals 4 to the x plus 2. Okay? First off, I need to evaluate my bases. So if I take a look at my bases, I've got a 4 on the left side and I've got a 4 on the right side. Because this is the case, I can solve this exponential equation. I don't have any extra work. This is already prepared to be solved. Okay? So the way I'm going to solve this is because these bases are the same, I'm just going to get rid of the bases. So when I do that, I'll be left with my exponents. So I've got 2x on the left side equals and x plus 2 on the right side. Okay, and this makes sense because 4 to the 2x, if it equals 4 to the x plus 2, this 2x and this x plus 2 must be the same expression. Okay, so all we did, we had the same base, so we were allowed to cross out the bases, and now we're just going to solve the equation that our exponents gave us. So we now have 2x equals x plus 2. So to solve this equation, what I'm going to do is I'm going to subtract x on both sides. When we do that, x's cancel on the right side. On the left side, I have 2x minus x, which is just going to be 1x, equals, and then on the right side, I was left with positive 2. So I know that my solution is going to be x equals 2. Okay, and of course we can go back and check this. If we were to take this 2 and we were to plug it back in for x on the left and right side, we would have 4 to the 2 times 2, so we would have 4 to the fourth. And on the right side, we would have 4 to the 2 plus 2, and 2 plus 2 is 4. So we would have 4 to the fourth equals 4 to the fourth, so we know that x equaling 2 would be our solution. Okay, so that would be an easier type of problem that we would face. Let's move on to this next one. Okay. We have 1/3 to a power of 3n equals 27. So first I'm going to check and make sure that I have the same base. So over here I've got big numbers of 1 and 3, and over here I've got a 27. Okay? I don't have 3 equals 3 or 27 equals 27 for this problem, so I know that I need to rewrite my bases. Okay? So this is how I'm going to do that. If I take a look at 1 over 3 here, I want to get rid of that fraction. So the first thing I'm going to do is, because I know this 3 has an exponent of positive 1, I can use my negative exponents rule almost in reverse and cross the line and switch the sign. So if I cross the line and switch the sign, I have 3 to the negative 1 all to the 3n. Okay? So all I did here was I got rid of my fraction by using my negative exponents rule, and I turned it into a negative exponent. Okay? I'll put my equal sign. So if I take a look at my left side, I know that I have a base of 3 here. Okay? If I go over to my 27, it would be really helpful if this had a base of 3, if it were possible, because then I would be able to use my other exponent properties to solve for n. Okay? Now this requires some thinking outside of the box. So is there any way we can write the number 27 with a base of 3? And it turns out there is, because 27 is 3 to the third power. Okay? At this point, because I have the same base, both of them are 3, I can use my exponent properties to solve for my variable. So on the left side here, I've got parentheses, which means I'm going to have to use the power rule. So when I do that, I will have 3 to the negative 1 times 3n, which is going to be negative 3n, equals, and there's really nothing I can do with 3 to the third power, so I'll keep it as 3 to the third power. At this point, I have the same base. I can't simplify the left and I can't simplify the right, but because I have the same base, I know I can just cross out my bases and write an equation using my exponents. So on the left side, I've got negative 3n equals positive 3 on the right side. Negative 3n, positive 3. From here, I will isolate my n by dividing both sides by negative 3. When I do that, I will end up with n equaling 3 divided by negative 3, which is going to be negative 1. And that would be my solution. Okay, let's take a look at some more examples. Okay, I've got some easier problems here and some tougher problems here. I think it's a pretty good variety. So, if I take a look at this first example problem, I've got 4 to a power of 2b equals 4 to a power of 3b. First, I need to check and see if these have the same base. And sure enough, they do. We've got a 4 on the left side and a 4 on the right side. Okay? Because they have the same base, I can ignore those bases or just cross them out and set the exponents equal to each other. So I've got 2b on the left side and 3b on the right side. Okay, so first off, to solve this, I need to get all my b's on one side. So how about I subtract 2b on both sides? When I do that, 2b minus 2b on the left side is going to cancel out. So I'm left with 0. And on the right side, I have 3b minus 2b, which is going to be just 1b. Okay, so at this point I have 0 equals b, so I've solved this problem. Okay, let's move on to number 2. So taking a look at number 2, first off, our first step always when solving exponential equations, we're going to check out what our bases are. So on the left side here, I've got a base of 3. On the right side, I also have a base of 3. Because of that, I can cross out my bases and set the exponents equal to each other. So I've got 3a minus 1 equals negative 2a minus 3. Okay, I'm going to get my numbers on one side and my a's on the other side. So how about I add 1 to both sides? If I do that, negative 1 plus 1 is going to cancel. So I'm going to be left with 3a on the left side, my equal sign. I've got negative 2a on the right side, and negative 3 plus 1 is going to be negative 2. Okay, now I need to get move this negative 2a over to the left side by adding 2a. When I do that, my 2a's cancel on the right. 3a plus 2a is going to be 5a. And on the right side, I'm left with just this lone negative 2. My last step to isolate my a will be to divide by 5. Fives are going to cancel on the left side. So I'm left with a equals negative 2 over 5, which you can just leave because we can't simplify that fraction. All right, let's move on to number 3. So taking a look at number 3, this is one of our first example problems where we're going to have to change our base. Okay, so if I am taking a look at this problem here, I've got 25 to the negative x equals 625 to the 2x plus 2. Okay, so taking a look at this, I first off kind of need to have an idea of what my base will be. Okay, so let's try and see if our base is 25. So if I've got 25 to the first power, I have 25. If I have 25 to the second power, I'm going to be way over 625. Therefore, I know 25 is not going to be my base. Okay, but just taking a look at 25 and 625, I have a funny feeling that 5 can go into both of those. So if I just write my exponents of 5 over here, 5 to the first is 5. 5 to the second is going to be 25. 5 to the third is going to be 125. And 5 to the fourth is going to be 625. Okay, so because of this, I know that I can write my 25 as a base of 5 to a power of 2, and I can write my 625 as a base of 5 to a power of 4. Okay, so I'm just going to rewrite this equation. So instead of 25, I've got 5 to the fourth, or sorry, 5 to the second, to the negative x equals 5 to the fourth to the 2x plus 2. Okay, now I have the same base on both sides, so I can go ahead and use the power rule and simplify the left side and the right side. So if I do that, I'm going to multiply my 2 by my negative x, and over on the right side, I'm going to multiply this 4 by the 2x and by the 2, similar to me distributing. So if I rewrite this, I've got 5 to the negative 2x equals 5 to the 8x plus 8. I've got the same bases here, and I really can't simplify the left or the right side any further, so I can cross out my bases and set my exponents equal to each other. To solve this, I need to get my x's onto one side, so how about I subtract 8x on both sides? When I do this, I have negative 2x minus 8x, which is going to be negative 10x. I'm going to cross these out, equaling my positive 8. My last step will be to isolate my x by dividing both sides by negative 10. When I do that, negative 10's cancel on the left side, and I am left with x equaling 8 over negative 10, but I know I can simplify that to negative 4 over 5. Okay, so I will advocate for all of you to, when you're trying to find a common base between your numbers up here, to go ahead and do this process over here. Okay, that's the best way to check. This is one of those things that the more we try to do it in our own head and try to make this into mental math, that's where mistakes start to happen. So even though it's going to take an extra 10 or 15 seconds, maybe just go ahead and do that. Okay, and you will notice the more you start to do this, the more you're going to be able to memorize all these numbers. Okay, let's move on to number 4. Okay, so number 4 reminds me of our second example problem way up at the top on the first sheet. Okay, I've got 1 over 27 to a power of b equaling 3 to the second power. So because of that second problem on the first sheet, I know that I can give this 27 a power of 1, and to get rid of the fraction, I can cross the line and switch the sign. So if I do that, write my new equation over here, I've got 27 to the power of negative 1, all to a power of b, equaling 3 to the second power. Okay? And because I know from that example problem up above that 27 can be written as a base 3, I'm going to go ahead and do that. So instead of 27, I can write that as 3 to the third. And that 3 to the third is to a power of negative 1. And this whole thing is to a power of b, equaling 3 to the second power. So just rewrote 27 as 3 to the third power. Don't forget your negative 1 here, so I put parentheses around my 3 to the third power and put my negative 1. And then this, of course, was all to a power of b. Okay, so now I have two similar bases, so I can go ahead and proceed with the power rule. So for the power rule, I'm going to work from the inside out. So I'm going to multiply my 3 by my negative 1. So when I do that, I'm going to have 3 to a power of negative 3, still to a power of b, equaling 3 to the second power. I still have parentheses on my left side, so I can go ahead and do the power rule again. When I do that, I'm going to have 3 to the negative 3b, equaling 3 to the second power. Because I can't simplify the left or the right side any further, I can get rid of my bases because they are the same, and set my exponents equal to each other. So on the left side I have negative 3b, and on the right side I have positive 2. To simplify that, or I need to isolate my b, so I can divide both sides by negative 3. Negative 3's cancel on the left side, so I am left with b equaling negative 2/3. Okay, let's go on to number 5. Okay, so for number 5, looks like we have a lot going on here. We have 64 times 16 to a power of 2r equals 64 to the negative r minus 3. So my first step always is to find a similar base. Okay, so taking a look here, I've got 64, 16, and 64. Okay, so basically what I need to do is find the common base that goes into 16 that will also go into 4. Okay, so if I do 16, let's start with that. I always like to start with my smallest number. So 16 to the first power is going to be 16. 16 to the second power, I can't even tell you what that is off the top of my head, but I know it's way over 64. So I can't deal with a base of 16, so I'm going to have to change all 3 of these. Okay? If I think about bases of 16, I know 16 can be written with a base of 2 when 2 is to the 4th power. Okay? 64 can also be written with a base of 2. But let's go a little bit higher so we're dealing with smaller values. So I know 4 to the first power is 4. 4 to the second power is 16. And 4 to the third power is going to be 64. So how about we go ahead and we rewrite our 64s and our 16 using base 4. So if I rewrite this out, I've got, instead of 64, I've got 4 to the third power. Instead of 16, I'm going to have 4 to the second power to the power of 2r, equaling 4 to the third power to the negative r minus 3. So when I do this, I'm going to first start off with the power rule, just get rid of all my parentheses. When I do that, I'm going to have this 4 to the third power, which I haven't touched, times 4 to the 4r equals 4 to the negative 3r minus 9. Okay? So at this point, we can't go ahead and cross out all our bases yet. Okay, on this left side, we want to group these bases together. Okay, before we solve, we want to have one base on one side and one base on the other. Okay, so if I take a look at this right here, I've got 4 to the third power times 4 to the 4r. Okay, how can I group those together? Well, I know these two things are being multiplied, so how about I use the product rule? So remember, the product rule tells me that I can combine these two bases by adding my exponents together. So I'm going to rewrite my left side as 4 to the 3 plus 4r equals 4 to the negative 3r minus 9. Because I've got the same base on each side, and there's only one of them, I can cross out my bases and set my exponents equal to each other. So I've got 3 plus 4r equals negative 3r minus 9. I'm going to add 3r to both sides. When I do that, 3r's are going to cancel on the right side. On the left side, I'm going to have 3 plus 7r. On the right side, I'm left with my negative 9. Scroll down just a little bit. Okay, now I'll move my numbers all over to the right side, so I'll subtract 3 to start off. When I do that, my 3's are going to cancel on the left side. I'm left with 7r on the left side equals negative 9 minus 3, which is going to be negative 12. And my last step is going to be to divide by 7 on both sides to isolate my r. And when I do that, I get r equals negative 12 over 7, which I cannot simplify. Okay, and leaving your answer as an improper fraction is completely fine with me. I actually prefer it that way, opposed to mixed number or a decimal. Okay, let's move on to another one. Okay, our last problem here. We've got 1 over 32 times 4 to a power of m equals 1 over 4 to a power of 3m minus 2. A lot going on here. Okay, so first thing I am going to do, I am going to get rid of all my fractions. Let's start with that. So this 32 has a power of 1 and this 4 has a power of 1. So I can cross the line and switch the sign to get rid of my fractions. So when I do that, I rewrite it over here, I've got 32 to the negative 1 times 4 to a power of m equals 4 to the negative 1 to a power of 3m minus 2. So now what I need to do is I need to find a similar base. So I've got 32, 4, and 4. So I need those bases to all be the same. Okay. So if I am going to try out certain bases, let's start with 4. So if I start with 4 to the first, I get 4. If I do 4 to the second, I get 16. And if I do 4 to the third, I get 64. Okay? Well, I skipped over 32 here, so I know my base can't be 4. Okay? So let's try something a little bit smaller. Let's try 2. So if I do 2 to the first power, I get 2. If I do 2 to the second power, I get 4. 2 to the third power is 8. 2 to the fourth power is 16. And 2 to the fifth power is 32. So I satisfy my 4 and I satisfy my 32, so I know I can rewrite this entire exponential equation using a base of 2. These 4's over here are going to be of no use to me. So if I go ahead and do that, 32 is going to be written as 2 base 2 to a power of 5 This 4 can be written as 2 to a power of 2. And same thing with this 4 over here. We've got 2 to the second power, all to a power of negative 1. And then this whole thing is to a power of 3m minus 2. So if we go ahead and do a bunch of power rules here, we can combine those, we can combine those, and then we can combine those. On the right side here, I'm working from the inside out. If I rewrite this, I've got 2 to the negative 5th times 2 to the 2m equals 2 to the negative 2 to the power of 3m minus 2. So I've still got power rule that I can do on the right side. So I'll take this negative 2 and distribute it to my power on the outside. On the left side here, I can do the product rule, so I'm going to rewrite it as one base and add my powers together. If I distribute, I get 2 to the negative 6m plus 4. Okay, I've got the same base on both sides, so I can cross out my bases and set my exponents equal to each other. So I have negative 5 plus 2m equals negative 6m plus 4. I can move my variables over to one side and my numbers over to the other. So I will add 6m to both sides. When I do that, 6m's cancel on the right. So I get negative 5 plus 8m equals 4. I can add 5 to both sides. Fives cancel on the left side. So I'm left with 8m equals 9. I can divide both sides by 8. So my final answer is going to be m equals 9/8. Okay? So for all these problems, we're going to need every single one of our negative exponent, or not our negative exponent, but just our exponent properties. One thing that I would like to discuss really quick that we didn't see on any of these problems, if you're ever given a fraction, so let's say instead of negative 1 over 30 or 1 over 32 in this problem times 4 to the m, let's say we had 4 to the m divided by 32, okay? In that case, we would have a fraction, so we would have to have quotient rule. Okay? So even though we didn't do a quotient rule example in any of these problems, that is something you very well could see, and we can take a look at some examples next week in class. The other thing I want to point out is if you have just the number 1, okay? So let's say in this problem, number 5, instead of 64, we just had the number 1. Keep in mind that any 0 exponent is equal to 1, okay? So even though 1 can't be rewritten to equal the other bases, it doesn't appear, we could always take whatever our desired base is and just set it to a power of 0, and then it'll all work out for us. Okay? I realize those two things I just said are a little hard to imagine without putting these to use or seeing some examples, but we will take a look at some examples in the coming classes just so we have a solid understanding of all the rules as they pertain to exponential equations. If you have any questions, please let me know. Have a good day.